Welcome to today's webinar, Best Practices for Managing Security Operations in AWS. Our presenter today is Armando Late. Armando is a Principal Security Architect with AWS. Today with us, we also have Ken, Holly, and Karan. They are the webinar moderators who will be engaging with you and answering your questions throughout the live presentation. Armando, welcome. The floor is now yours.
Thank you. Thanks. Hi. Hi, everyone. Thanks for joining today's webinar. You already know my name, Armando Late, but I'm a security architect within AWS Professional Services. And my day job is essentially working with our customers in operationalizing their share of the shared responsibility model. So I spend a lot of time with AWS customers, helping them build security capabilities on AWS, optimize them, and also transition them from practices that they may be using in traditional data centers and modernize them to bring them to the cloud using the AWS services. Today, we are going to cover three things. We will talk about a basic framework to achieve security operations excellence. So an easy way to get the right secure outcome when building security operations capabilities on AWS. We will discuss how we are going to leverage AWS services to implement these capabilities. So we will not focus so much on going through individual services and now to configure them according to a certain security baseline, but we will talk a fair amount about how to use a number of services to improve the way in which you do security operations. Lastly, and I believe it's the more important bit, I will leave you at the end with a take-home toolkit, right? It's all fair and good to talk about it, but I would like you to try it by yourselves as well. So towards the end, I will leave you some content which will allow you to quickly put into practice and experiment with some of the concepts that we'll be talking about today and to try by yourselves. And as a teaser, we'll also talk about an opportunity to actually join me and the rest of the team to try some of this stuff hands-on and in practice. In a bit more detail, so our agenda, we will start with the customary introduction, which we are going through now. Then we will pretty quickly go to the nitty-gritty. So talk about this framework about control, monitor, and fix. Within the control side, we will touch particularly on AWS Identity and Access Management, the CodeStar services, and the CloudFormation and Config. On the monitor, we will look into some of the sources of log data that are available on the AWS platform. And on the fix side, we will talk about Lambda and also CloudWatch events a fair amount. So when we detect some kind of anomaly, how do we get back to known good? After talking about those three components, I will share with you a demo. The demo that I will share with you is fairly practical. So it's something that I've implemented with our customers, and that it is, with slight variations, but that it is up and running in production environments for very large deployments today. And as I mentioned, we will have our take-home kit at the end. As I go through control, monitor, and fix, I will also highlight two things. One of them is what I call a minimum security baseline. Minimum meaning what is the basic set of steps you should take to meet a bar to operate in the right way from a security perspective. And pro level meaning after you achieve that minimum, what is the aspirational bar that you should go to? Where we see customers that are higher performers in this space, that's the kind of things that we observe with them. With all that being said, let's get started. Roughly 2 years ago, AWS released the Cloud Adoption Framework, which is a framework that captures some of the patterns that we observed with our customers for success when moving to the cloud. The Cloud Adoption Framework itself, covers a number of areas. It is split into 7 different perspectives, like people, infrastructure, and so on. And there is also one perspective which is focused on the security side of things, the security perspective. When you read that document, which if you haven't had a chance to do it yet, I definitely recommend you to do it, you will see that it breaks the way we approach security into 4 components, directive, preventive, detective, responsive. What we talk about today, it aligns very closely or mirrors very closely what is described in the cloud adoption framework. When we're talking about control, essentially, we are talking about preventative, things that drive the right behavior, right? Mechanisms that we implement to drive a secure outcome. When we talk about detective, we are primarily talking about monitoring, logging and monitoring. So the things that allow us, and the mechanisms and the data that allow us to ensure that over time, the controls that we implemented before, that they remain effective and that they continue to operate as they should. And thirdly, responsive, right? If on the monitor side, at some stage, we detect that something is no longer operating as it should, that requires some kind of intervention, we want to make sure that we get it fixed and they get back to known good. So control, driving the right behavior, monitor, maintain and assure over time, and fix, it's about getting back to known good. I'm talking about 3 things, but there is a 4th there on top, the directive side. And the fair question is what we mean by directive and where does it fit into the framework we are talking about today. Directive tends to be, not tends, it is associated with policy aspects, compliance, strategic intent, and principles. So for our presentation today, we are going to keep it, streamlined, right? We have 3 operating principles that we try to adhere to, or that we will adhere to. We will think of pipelines and workflows, not isolated controls. And what we mean by that is that, security controls very rarely operate in isolation. They are a component of a much larger system. Also, there is a whole cycle associated with them, from design to build to test to deployment and operating effectiveness over time. So when we think about security controls, we need to think about that whole cycle to make sure that they work as we expect. Logging is fantastic, and as we'll see, in the AWS platform and even operating systems, databases, etc., they provide a lot of logging information, and it's good to enable and to get those logs, but we should do something with it, not just collect them, right? Lastly, the SOP is code, and by SOP I mean the standard operating procedures. In the past, sometimes the SOP tend to be long documents, a series of steps that when there was a need to respond to a specific event or perform a certain action, you just go and tick a list and go down that procedure to execute it. Still valid nowadays, but ideally we want to minimize the chance for error. We want to increase speed. So as much as possible, we want our SOPs to be in code, meaning that one single step gets executed, and that will in turn automatically take care of executing the 10, 12, 15, 100 steps that are required to complete a full SOP. Our mantra is we will automate all things. As much as we want, we love code, we want code, our SOP is code, and as much as we can, we will be automating everything. Let's get started. So what I'm going to do is take each one of these one by one, and let's consider a scenario in which we are, starting from scratch. We just created our first account on AWS, and where do we go from here? So the first thing we want to do is control. So build that initial set of mechanisms that will drive secure outcomes. We often refer to that as building guardrails. So it's not about putting blockers so much, but just about putting the right things in place that will drive the right kind of usage and secure usage by our users. We will look into 3 possible options: identity and access management, AWS Identity and Access Management, CloudFormation, and CodeStar. I have code star, but actually we will be focusing primarily on code pipeline. If we were to think from a best practices perspective on what happens on the control side, individual users, least privilege, use of groups. So in a way, common sense things that apply to an environment. Pro level is ability to scale those common sense things across much larger deployments, across N accounts. Let's start from the beginning. The first thing when you set up an AWS account that you need to take care of is the identity and access management. So this is essentially a service that controls all activity that your users will be able to perform on the AWS platform. For those that may be newer to AWS, just a whirlwind tour, which enables you to control who can do what in your AWS account. A number of options to do that. You can do that by users. Think of that as humans for a second. You can aggregate those users into groups. So let's say if you have certain categories or roles of users, certain categories of users that have similar jobs and they require all the same permissions, you can aggregate those into groups and assign specific policies with those groups. You can also have roles. And roles, I mentioned that word a second ago and I slowly backtracked. Roles have a very specific meaning in the AWS IAM world. They are essentially permissions that you can assign to resources or to other services. For example, an instance or a service on AWS that will take actions on your behalf. And obviously you have permissions. I would highlight a couple of things in the way in which our IAM policies are evaluated. The first one is that it always starts from a deny. So by default, you don't have access to do anything. Anything that is explicitly denied will take priority over anything else. After explicit denies, it's explicit allowed, right? Things that you state clearly that a user is able to do. And in the end, if there is nothing that matches the action that the user is attempting to take, that is equivalent to a deny. I will not go through all the 11 IAM practices that I have listed on screen. Some of them, quite clearly, right? Use least privilege. Use individual users, right? No shared credentials. I will highlight just a couple which are very specific to the AWS world. One of them being the auditing side. We'll talk a bit more about that. And the use of something called AWS CloudTrail, which essentially is our logging mechanism that journals all the calls to our APIs so that you can see, what users are doing or what kind of actions are being performed against your account, both from an accept and deny perspective. And I would also highlight the last one, which is when you create an AWS account for the first time and you register, essentially use an email address, and the ability to log on with that email address and get access to an account is referred as root access, right? That should be the first step, which is create a new user that will be administrator that you start using going forward and avoid the use of root credentials. The 11 practices that I'm not going into much detail in there as they are well documented online, so in our documentation and also in the AWS Security Best Practices white paper that I will talk about a bit later on. But let's now assume you have your first account, you are starting to do some deployments on AWS. Where do you go from here? Two common decisions is, should you use one multiple account and use controls within that account to separate your users and potentially the input applications, or could you go into multiple AWS accounts? Meaning that the main change between one and the other is what you consider to be your boundary, right? If you go with multiple AWS accounts, your boundary is an account. There's pretty much complete isolation. You could almost think of users in different accounts as if they are essentially operating completely separate and segregated data centers, so to speak. You can still, if you wish to do so, establish connectivity and so on. But it is a move from having a boundary that may be based on IAM purely within an account to a change in which the boundary becomes, the different accounts. When you have different accounts, you obviously need to consider how can you make all the controls that you are going to design and deploy, how do you make those repeatable across, n accounts. Here's an example of a potential way that you could structure the way that you use IAM, right? So you could have a billing account, essentially administrative purposes, where you aggregate all the costs that different accounts used by different users or different business units are using, and you get central visibility and also a central bill that you pay from. It could be that the driver is that you want to split the different environments, say dev, test, production, or sometimes it can easily be that what drives to that segregation could be data classification itself, as we are in the security world, right? It could be that you want to split applications from a lower classification from those that are processing your more sensitive data, that are handling your crown jewels. Worth also looking into the right and consider the two accounts that I have there, which in a way they are administrative, but they are providing specific security functions. So to do with security audit account and also logging, where we aggregate all the data that we'll be using. Now, deploying and controlling such a large number of accounts used to require a bit of work, but fairly recently it has become a lot more easier and convenient. Not long ago, if memory serves me right, roughly a month ago, we went with general availability for AWS Organizations that was originally announced at reInvent. And essentially, what it allows is, besides the billing that you already had in some way, is also to do things like centrally managed policies to define what kind of APIs and services can be used in individual accounts. It also allows you to much more easily automate the creation of new accounts as you need it. Two very fairly common use cases that organizations comes to meet is the first one is that control of the use of AWS services, so that it complies with your own internal baselines. So a centralized set of controls that you can distribute across many accounts. And also the automated of creation of AWS accounts, which I'm quite particularly fond of. Particularly because that allows you to do something. It allows you to, make API calls to create a new AWS account. Let's say that I want a new test environment or a new dev environment. I can make that API call. When I get the result from that API, I can automate the creation or the deployment of the security controls that I need before I release that account to the users. For example, using CloudFormation, which is a good segue into CloudFormation. For those that may not have used it before, CloudFormation is it is a service, definitely, that allows you to template your infrastructure. In a way, define how your environment looks in AWS, and you define that as code, which is written in JSON or in YAML as well. But it can be from things like, for example, specify that you want to have CloudTrail enabled and that you want it to be centralized to an account where you are aggregating all the logs. Can be specifying that you want standardized, templated network infrastructure, so you define your VPCs and what those should look like, and potentially even pre-create some security groups and network access control lists to allow you to control the flows. So you started with IAM, your first account. We moved to organizations where we started creating those sub-accounts for our users. We are now in the process of using CloudFormation to deploy a series of controls that we assign or that we require every single user to have, and that drives the right secure outcome. I know that when said it like that, it may sound a bit like, right, you have CloudFormation comes on one side, magic happens in the middle, and security happens at the end. it's not as linear as that, right? This deployment task, we need to care for it, and that in itself requires the use of certain security controls themselves. A good pattern that we like to use is to use particularly continuous deployment and with code pipeline to ensure that when we create our CloudFormation, that it's actually doing the right things, and that we get sufficient assurance at the end over that code that we've written with that will accomplish a number of infrastructure tasks to make sure that the end outcome is a secure and safe outcome. Let's look briefly at 4 stages for delivery for continuous CD pipeline and the kind of security tasks that we could accomplish in there. So, could be the commit, and commit is when I push my code to the repository, to a repo, and I do a first set of checks, static code analysis, right? Essentially using code, using tools that will look at the code itself, at the CloudFormation template, and validate a series of heuristics to make sure that nothing bad is being done there. If my commit phase succeeds, I can go to an acceptance phase. In acceptance phase, we are talking about actually launching the CloudFormation template in a sandbox, so to speak, and run a battery of tests against it. It could be running network scanners, could be just syntactic checks and make sure that everything stands up as it should. Could be any kind of test associated with that acceptance phase. Prior to releasing, we get close to a pre-prod environment and run a third battery of tests, making sure that the infrastructure that we are proposing does meet business needs, for example, from a load and performance perspective, and as well for more active security testing like penetration testing. Assuming all of that succeeds, we move into production, meaning we deploy, and now it is at the stage in which this template represents our baseline of what our infrastructure looks like, and users can start getting it deployed in their accounts as they get created. All that I just described can be accomplished using the pipeline that I have on screen. So essentially in this case what we have is code pipeline. When we do that commit, the code analysis, the static code analysis could be done by Lambda, so we hard code our own heuristics. When we go into acceptance, we do have a number of dynamic security tests that are once again triggered by Lambda. And in this case, we say if we want a human to actually validate that those security tests succeeded before proceeding. And if everything passes and gets manual approval, we can tear down the stack that we have in acceptance phase and release it to production, right? Talking about it is great. I will come back to this example in a little bit because we will share with you the code for this pipeline and the checks that are implemented. So bear with me just a few moments. So far, what we have is account creation. We define an initial set of guardrails, which is based on the policies that SCPs service control policies that we defined in AWS Organizations. Then we have a series of initial controls that we deploy in CloudFormation, and we have our CloudFormation as we release it. We are performing a battery of tests against it, including security tests, to make sure that it does the right thing. Now, as I'm sure you guys will relate to, and girls will relate to, is when we design and build security, that initial release of making things available, it's probably the only time where you can say that it is operating according to our spec. If not cared for, security controls have this tendency to erode over time, right? Exceptions starting to build up, things start operating as they should. Someone tinkers with something to accomplish a quick task and forgets to bring it back. So it is essential, if we want to maintain operating effectiveness over time, that we keep track of how our controls are operating and making sure that they are still operating against the baseline that we defined at the beginning. besides the assurance aspects of guaranteeing us that we are still operating as we expect, it also allows us to detect anomalies and change. So if for some reason something were to deviate from what we expect, we will be able to take action. I'll add 3 dots at the end in the options there, simply because there's a vast amount of log data. I'm only highlighting the ones that are very AWS specific in a way, but pretty much every single service will have additional data that you can use and that you can process from a security perspective. The first thing I'd say from a best practice perspective is get that log data, right? You won't realize you need it until you actually need it, right? So, sorry, you won't miss it until you actually need it. So make sure you enable it so that, if it were ever needed, you have it available. And when I say ever needed, it doesn't even need to be something to do with security. It could be something just to do with general troubleshooting. Pro level, so top performing organizations is, when you are getting that data, that stream of data coming through, and as close to real time or pretty much as it is arriving, start processing it. Implement basic or complex, depending on your appetite, heuristics that will look into that data, and if it detects something that requires attention, that it raises the required alarm, that it acts on it as the data arrives. Yeah. I mentioned earlier CloudTrail, and just for those that may be newer to the platform, as I mentioned, CloudTrail is a managed service, and essentially it is the service that logs all API calls that are made on your AWS account, and it also logs all the console logons as well. So people accessing the platform through our console, it will also be captured in CloudTrail. Those API calls, they are captured regardless of how you access. It could be code that is calling it, could be the command line, the console, could be an AWS service that you instruct to make calls on your behalf, or could be an instance that you assign the role and that is making API calls on your behalf. All of those will be captured and will be recorded. After setting up the identity and access management side of things, very shortly after, talking seconds ideally, the first thing you should do is really enable CloudTrail, and it should be enabled on a global basis. By the way, the reason why I say it should be enabled on a global basis is CloudTrail will capture activity that is happening on a per region basis, so, depending on the endpoints that you are calling and their location. And it could be, let's say, for a second that you have no operations or you are not using the London region at all, right? You should still enable it, simply because from a security perspective, if all of a sudden you start seeing activity in London, that is a very high signal, low noise indication of an event that you want to look into, that you want to investigate, right? This location or this region where we don't have any operations, why are the users, testing it there? Let's find out. Also, if you have it enabled and no activity is being recorded, so nothing is happening, there's no charge for it. You only pay for the storage of the logs themselves, and the logs are only generated when someone or something is performing API actions. When we look into our world with multiple accounts, we mentioned that we ideally would like to start aggregating some of the log data. The pattern that I have on screen is one that we've used with a fair amount of customers. There are many variations, but this particular one tends to be particularly popular. So let me briefly walk you through it, right? So first thing, we go into each account and we enable logging and aggregation. So what I'm saying is that we enable CloudTrail and we instruct CloudTrail to send the logs to a centralized bucket. This enabling of the logs, when doing it in practice, more often than not, you'll be doing it either with a command line or with a small CloudFormation template that you can provide to the account creator to run it. So run that CloudFormation template, small snippet of code, and it will automatically start aggregating the logs. We have logs, we want to do something with them. So they start arriving in our S3 account, S3 bucket in the security account. When a new log file arrives, we set up S3 to send an SNS notification. So SNS is a simple notification service. That will publish messages to what we call a topic, and anything or anyone that is subscribing to that topic will be notified that there's a new log file arrived. A very reasonable subscriber could be a series of Lambda functions implementing different kinds of heuristics to validate if the action that just took place, if it is, if it is valid or if it is something that we need to do something about. A good example of that could be, let's say someone switches off CloudTrail on that account. Switching off logging, it's something of interest and that we want to investigate. So we could have one of these lambdas that is just checking to say, is CloudTrail operating as it should, or has any API activity taken place that has blocked that is disrupting our control, in this case, the CloudTrail monitoring from operating. We can, and I strongly advise that it has a lot of value, further enrich log data with additional context. For example, if you have an alarm happening in a sandbox account, you will handle it very differently than if it is an alarm happening in your most sensitive account. The sandbox, likely you will have much more tolerance, and it will be something that will be low on your priority queue to look into. If it's something that is in one of your production applications or production workloads, likely you want to respond as soon as possible. If dictated by the rules engine, so after that assessment, we get a notification. In this case, it is something in the production. Please go and take a look now. An option, if something is not worthy of immediate response and investigation, is to just index it, keep it in storage, generate metrics about it so that we know overall what activity in our deployment looks like. And all processing, the good thing about this model that I described is that all this processing is taking place within the security account. Once these accounts on the left, they start sending our logs to this bit here in the middle, we essentially can refine our heuristics, add new ones, remove, do all kinds of processing with the data without having to go and knock on each of these accounts each time saying, hey, I need to try something new, right? So we get out of the way of the business as well, which is always a good thing. Besides CloudTrail, another service that we use very closely to it is Config. Config essentially is, I like to think of it as a black box recorder for the AWS platform. It is monitoring resources themselves and changes in those resources. For example, in EC2, you have the ability to create security groups, which essentially are like a stateful firewall, not like they are, a stateful firewall that controls the flows, the network traffic that goes in and out of your instance. If someone makes a change in that security group, Config will capture that and will record, this is what the previous state was like, this is what the new state looked like. Config also comes very closely with something called, a sister service in a way, called Config rules. Config rules allows you to do more. It allows you to validate also the changes against a set of compliance rules that either you can use a rich set that we provide, or you can create your own as well. And what allows you to do is, let's say the change in that security group was to open it to the world, right? Which is a bad thing. You could have config rules and automatically there's a notification that goes on. Think of SNS like just before. and we have subscribers that say, hey, I just picked up something from SNS and I need to take action. Different ways, S3 as well, just looking at all the history of different changes that happen, and also API access. So config in itself, just a couple of screenshots about it, the kind of things that it will do and what the interface look like. It will evaluate if the traffic is, in this case, it's evaluating if SSH has been open to the world, and it is saying, yes, I just picked it up. It applies to that security group. Take a look at when that happened and take a look at what the changes happen, and you can take action. And this is, an elaboration on that. Obviously, operating in isolation can also be troublesome, as described before. So you can also have the option of using that pattern we had just before to start aggregating CloudTrail, and now we are aggregating config data as well, and we have our logging aggregation / security account, and with the same set of capabilities that we talked before. We are no longer just talking about, in this case, having an email or an alert, but we're talking about, maybe direct integration with your ticketing systems or with the dashboards or SIEM tools. This same pattern applies to other kinds of logs, flow logs. Flow logs, by default, they get ingested into a service called CloudWatch, which resides in each of these accounts. We could have CloudWatch. It's aggregating flow logs, essentially, the flows of the network flows on a given VPC or on a given instance. And we can have those, for example, using Kinesis FireRose to stream them back, once again, to our central aggregation account, where we can have, Lambda or anything else that is looking at those flow logs and make sure that they still make sense. So at this point, we are looking at things in the platform, and also now they are happening and evaluating them, and also looking at them at the network level. Lastly, on our 3 steps, we have the fix, right? If our monitor side detects something, we normally want to fix it or investigate it, and after investigation, fix it. We want to go back to known good. Sometimes the fix can involve, just getting rid of what was bad, right? Let's say you have a fleet of 100 web servers. One of them starts, let's call it misbehaving for a second. You may just want to get rid of it and just launch a new one from known good. We need to be measured in doing that, in the sense that we don't just want to throw out the baby out with the bathwater, meaning that we don't want to go into cycles in which we start terminating things very quickly in response to a specific stimulus without really knowing what it is causing and dealing with the root cause. So it should not always be just about throwing it out. Lambda particularly shines in this space, but a lot of other AWS services play a role. Best practice, minimum security baseline, I'd say automate the alerting, right? Something came out from monitor and you automate the alerting, making sure that it gets to the right place, ideally a ticketing system. Top level, it would be closed loop. And what I mean by closed loop is those situations in which you can have the monitor detect something, and then you also have the logic and the code to automatically remediate it and return to known good with minimal human intervention. But as I mentioned before, we need to be measured when you do that. So spectrum of options within the fixed side. Typically, if you are on the bottom left, meaning you are getting a lot, maybe you are getting a lot of data, but it is an event that is happening all too often, almost close to a false positive. Those are the situations in which likely you will not do nothing. We're not talking about throwing the baby out with bathwater. Those tend to fall in this side. You will likely want to measure, right? You want to make sure that if it is a case in which you need to refine your heuristics or if it is a sign of something else. Enriching log data provides you with context, makes it relevant to your specific organization and your use case. Alerting comes next, right? Now we are actually getting this information to people that can deal with that. Correct is when we get into the closed loop. We are taking a direct action to fix the problems. and we talk about stop, it could be that there are circumstances where we determine that the right course of action when a certain problem occurs is to actually terminate it straight away. We just kill it. So we could break those 6 into 3 categories, which I think is a good warning. Things on the bottom left fall into the awareness space, in which alert indirect. And indirect essentially means that the platform and your automation detects that something has happened, but is dependent on a human to actually fix it. And direct action, where we have an end-to-end, a closed-loop system. Quite a few options available to deal with things in this space, and I will go through them just very briefly in the demo that I have laid out for them. I would emphasize the need to always test these things, right? Testing not just in the code pipeline we do, but something that we do with our customers as well is what we call security incident response simulations, in which we build together with the customers holistic scenarios that are relevant to them, risks and threats that they feel are particularly relevant, and we simulate, typically over the course from half a day to a day, how their environments, both from a technical and people perspective and process perspective, would respond to that. There's been a couple of presentations at reInvent on this topic that I definitely recommend you guys watch. So, control, monitor, fix. Let's try it in practice. Yeah, let's try it in practice. Let's think for a second that we have a fairly standard application, right? There's a web layer, mid-tier, and it has a data layer, right? Standard 3-layer application. When we are in normal operation, we have a number of controls in place. We have agents loaded into our EC2 hosts, instances, that are sending syslog back to CloudWatch, so aggregating OS data. We have flow logs enabled for some of our subnets, which once again are being aggregated as well. And we have CloudTrail. So just from that, we can say that we have visibility into the operating system, the network, and the platform levels. That's our monitoring side. On the control side, we have our agents to aggregate those logs, and we also keeping track of logons. Nowadays, most it is seen as a good practice that you don't log on to a host, and if you have a problem, typically you may want to just rip and replace. But there are circumstances that can lead you to require a logon, so we will keep track of those. So, there we go. So if I want to log on to my instance, what I'm going to do is first I'm going to request a ticket, essentially a ticket from my internal ticketing system to say, hey, I need to go to that instance. This comes with something back which essentially says, yeah, that logon is going to be approved. I go and I do EC2 user at the host over there, and I log on to it, right? I do a couple things like list some directories, get my activities, wherever, and I'm done and get out. Now, from it seems like, very simple, right? I just did an SSH and logged up recently and got out. But actually a few things happen in the back. I did that SSH. As I did that, there was a request that went from the host to CloudWatch using CloudWatch events that is saying, hey, is this logon okay? And something is coming back saying, yeah, the logon is okay. What that leads to is that, not much happens. We are business as usual. But let's assume for a second that I go back to that host and, either because I forgot to request my ticket, or I forgot to request my ticket, or maybe someone could have compromised those credentials, we don't know. And I'm starting to wonder, I just go in, I did request a ticket, right? So things start to get a bit more interesting, right? You saw that just on my email, 2 things popped up. EC2 user has logged on, and second, flow logs have been started. Here's what's happening in the back. Is logon okay, just like we did last time? Logon is okay? Sorry about that. Is logon okay? No, logon is not okay. At the same time, I'm accessing the instance as a regular user. So this is the kind of event that I'm interested in, but not sufficiently interested to take active action to fix. But from now onwards, I will want to track it very closely. And there's quite a lot happening in the back, right? That event, the not okay, means that a couple of lambdas that are changed were triggered and new ones launched. Those lambdas, they did a series of actions. The first one is one of them is now subscribing to the syslog feed. So it's looking for activity inside the instance and seeing what is going to happen next. A second one did two things. It enabled flow logs just for the instance that I'm suspicious of. And second, those flow logs start coming to CloudWatch, aggregating. And third, it also subscribes to them. So it is an event of interest, doesn't warrant me taking active action, but I'm doing something about it. I'm very watchful right now as to what happens next. So let's say that I'm still on this host, and you see here that the email in the meantime came saying that my varlog secure subscription has initiated as well. And let's say that whoever is in there, by hook or by crook, they now escalate their privileges, right? So far, as a regular user, this was something that I was, willing to tolerate in a way. But now, you may not hear my keyboard, but nothing is happening when I type, right? So, until now, things were interesting, I wanted to watch, but I would take no action. The moment that I escalate my privilege to root, I determine in my own organization that is something that is worthy of intervention. That is something that I want to respond immediately to. So we see that in the administrator comes thinking something saying, hey, we detected a root installation, a root escalation, so we are going to take action straight away. And the action is remove from auto-scaling group so that it no longer receives production traffic and isolate that instance. Let me walk with you a bit more detail, because there was actually quite a bit more that goes on in there. So, instance, I log on as root. You remember that I had a lambda subscribing to my syslog data? That lambda detected that there was a privilege escalation. And it knows that the next thing to do is to intervene to get back to known good and isolate the problem. It does three things by chaining other lambdas or other automated responders. First one is isolate the instance. You saw that I lost connectivity, right, on my SSH session. So it deployed the security group that blocks all traffic. Second, it deregisters, meaning I no longer want that anomalous instance to continue receiving traffic. And third, I will want to find out what happened. So it is taking an automated snapshot, essentially creating a copy of the volumes associated with that instance for forensic analysis, and leaving it on the side, isolated, also for my incident responders and forensics crew to go and look into what exactly was happening there. So we switch from that enhanced mode in which we were just looking at additional telemetry to situation in which we see the signal is high enough that I want to intervene. And we took a number of steps to do that. The outcome is that we are back to the first diagram, right? We are back to known good. If I go back one slide, you see that auto-scaling in the meantime also is not aware of all the complexities of what I just did. It recognizes that my web fleet is one server short now. So to deal with that, it launched a new one from known good. So we are back to our original deployment. We just need now to do the investigation that our application continues to operate as it should. So we covered quite a bit of ground there, right? Control, monitor, fix, the services that can help with that. Our control is about creating the right guardrails, and we talked about how to use things like identity and access control, identity and access management to do so. We talked about the monitor services, and one thing to never forget is data is good. It is better if you use it. it's even better if you use it to drive automation. And the fix is not just about the speed of response, it's also about freeing human intellect to other tasks that are more valuable. I promise you 4 things, or I promise you a take-home kit. So 4 things that I would like to leave with you. The demo code that I just ran through with the Lambda responders and the subscription to different log files, we have published that, so download it, test it, deploy it yourself. I hope it inspires you to come up with your own set of use cases. The pipeline that I described in the control stage about validating CloudFormation against a set of heuristics using Lambda and so on, we also published that, so you can go through a blog that will describe step by step how to implement it, and also comes with artifacts to simply click on a couple links and get it up and running. Question that I get often after talking about this topic is, so what should I control, monitor, and fix next? Our security best practices are a good source of inspiration. When I talked about 11 IAM best practices, each one of those could be something that you implement through control, monitor, and fix. And number 4, which is optional, which is come jam with us. At re:Invent 2016, we ran for the first time something called the AWS Security Jam, which essentially is an opportunity for our customers hands-on to work through a total of 10 exercises in a gamified environment. So you get points and you get prizes as you complete them. We will be running this year in a number of venues. If you are at San Francisco Summit, April 18, 19, we are there. Public Sector Summit, we are there, and there will be at others as well. If you happen to be there, come and say hi. I'll be around, and we look forward to talking with you and discussing your use cases. We also have the possibility of running the Security Jam privately, so just for your organization. Typically, we are looking at 50 plus people to be able to organize it. But if it is something of interest to you, do reach out to your account manager, and we will make sure to get it arranged. With all that being said, really appreciate you taking the time today to join us and to watch the webinar. Hope it has been helpful and that has inspired you to also go and start building those control, monitor, and fix mechanisms. Thank you so much, everyone.